We are based in Hubli in the incubator at the Deshpande Foundation. The problem, the social issue or the problem that we're trying to address is that of contaminated water. Next slide, please. So this in a line sums up what Aquasafi is trying to do. We intend to provide safe water to underserved communities at affordable price points through a sustainable business model. Next slide, please. Obviously, everybody is aware of the problem of contaminated drinking water. It's a problem all over the world, especially in the developing world. There are figures here, 880 million people across the developing world don't have access to good drinking water. Different surveys, different census results. In India, about 144 million don't have access to good water. In Karnataka, there have been surveys which have said 60% of villages that were tested had greater than 1 part per million of fluoride. A high level data, but what we're trying to really say is that it's a large enough problem for which there probably aren't enough solutions, or enough is not happening right now. So that's the space where we wanted to address. Next slide, please. We started with 5 villages in Gadag district. Gadag specifically had a problem of on multiple parameters, so turbidity, total dissolved solids, fluoride, and so we kind of identified what the problem was, and just showed out what health problems are caused by these issues, and then we said what technology would really solve this problem. Reverse osmosis is something it has been used by several other players to purify water where there is mineral contamination, where there is bacteriological contamination, etc. There were a few problems with traditional reverse osmosis systems. One being the electricity consumption was high, and 2, there was a lot of water being wasted. So we said, why don't we try and address these 2 main problems and come up with a solution. Next slide, please. So we came up with a really compact design which provides 1,000 liters per hour of purified water in a 2 feet by 2 feet unit. And that's the footprint, about 5 feet high. So really a compact system versus you typically have almost a 10 feet by 8 feet kind of a system for 1,000 liters per hour. So we came up with a compact design that uses significantly less electricity and which so there is something called a reject percentage with reverse osmosis. So typically it's 50-60% for industrial sized machines, and we were able to reduce that to 30%. So that was on the technology side, and in order to actually scale it up to people, we had to have strong processes, so we came up with that. So these are the set of things that every operator needs to do so that the machine, the membrane, has a long life. This is how we maintain it. This is how the systems maintenance guys need to follow. So we did all that, and then we also said this. We also need to do a daily performance monitoring so that we can guarantee the water quality on a daily basis. So we're looking at the water quality and also the system health. So we did that. Next slide, please. But that's all of that is one part of the solution where you're looking at the technology. The more important piece is, once you have this, how do you really take it to people and make sure that people are getting this pure water at an affordable price. So we said that we'll partner with community NGOs which are already present in underserved villages and underserved communities, and we would also partner with local entrepreneurs who are present there in those communities, who are who understand the market like nobody else does. So if we set up a store, there would be a question of credibility, and there would also be a question of us knowing the market. We would try to sell water, but we wouldn't know the local intricacies there. So we started with we started doing pilots with large community NGOs. SKDRDP, Shri Kshetra Dharmasthala Rural Development Project. It's a large NGO in Karnataka. So they were our first customers. We started a pilot with them in the Gadag district, and started with 5 villages 2 years back, and then now we have grown with them. Now we are their technical partner all over Karnataka. And having done that, we also said we will try and work with entrepreneurs, local entrepreneurs. The issue there is, how do you, the unit itself costs about 3 lakh rupees. So how do you have a local entrepreneur purchase that unit? So we said we would have to enable loans and make it available to them easily and at a low interest rate. So we were lucky to, so through the foundation, we were able to connect with microcredit institutions, Microgram right here and Milap. So they were able to offer low interest loans, which in turn we used to provide loan to the entrepreneurs. So we have started that model. We in the next few months we would be setting up about 11, 12 such units in the entrepreneur model, where the entrepreneur gets a loan, he purchases our unit, and then he sells the water. Now the selling price of the water, so it needs to be sufficiently low so that people buy, but it has to be sufficient for for it to make sense to the entrepreneur. And another aspect that we look at here is the support from the local government. So especially with sale of water, there's a lot of so you would need the support of the local government to make sure that you have so it keeps running without obstructions. Next slide, please. So having established the model at a high level, once we started looking at villages, so we identified some parameters, a set of parameters which would qualify a village where we would set up a water unit. So typically for 1,000 liters per hour unit, we look at a village that at least has 1,500 families, and which does have a recognized demand for a recognized problem of water contamination. So there should a problem should exist, and people should be aware of it. So that is something that we look at before we set up a unit in a village. We also need power supply. Power supply is very intermittent in most of the villages, but wherever we have operated, we have found that at least 12 hours supply. It could be in the night, it could be sometime in the day, it could be over tranches, so 3 hours in the morning, 4 hours in the evening. But we do have up to 12 hours of power supply. So that much is enough for us to have a unit work. So as long as it works for 8-9 hours, we are able to generate enough water to supply for the entire village. So another way in which we work with the Gram Panchayat is in order to reduce the total capital cost, we see if the Gram Panchayat usually has a vacant room available. So if they're able to provide that room to the entrepreneur, that helps the entrepreneur bring down his initial capital investment. We also get the water connection, electricity connection from the Gram Panchayat. And in order to identify entrepreneurs, we have a checklist that we follow, so that we kind of try to minimize the risk of the entrepreneurs leaving midway once they start our. Next, please. In terms of impact, we have about 25 units right now, and each unit on an average serves about 300 households, which is about, so typically 4 to 5 people in a household. And the impact in terms of the rupee amount, so if you look at the healthcare cost that it has saved, we haven't really done a survey, but then it should be significant, where if you there are other neighbors who do not consume good drinking water. So typically once in 2 months or so, they would have some kind of stomachache problem or whatever. So they would spend money on preventive health care, on sick care, so to say. And I think key going forward is to demonstrate the entire water unit model as a viable business for an entrepreneur. So that is one side of it. And secondly, we to really scale these water stores, we would need to demonstrate that it's a credit-worthy business for the lenders, so that we could also have banks and other lending institutions show interest in supporting this initiative. Some photographs here. This is The first one is a photograph of two kids who suffer from dental fluorosis. Fluorosis is very common in Gadag. You just ask anybody, any kid to smile and will probably in Gadag. So this is typically when we go to a village, we have a small demo unit. It's you can actually see it in the stall that we have outside. We take it to the village. We use that for awareness creation. We spend about 3-4 days in any village before we start a unit there. Next slide, please. Operator training, we do have set processes and procedures that we train our operators on. So these are with the Dharmasthala Trust, the operators, a recent training program that we carried out. This is how a water store looks like. You can see villagers coming with 20-liter cans. These are food grade cans. They pay in advance for the entire month. They have I don't know if it's visible, but they have small cards that each of them is carrying. So these are monthly membership cards. So they prepay for the entire month, and then every day they pay 60 rupees for the month. So they get 20 liters every day. And yeah, this is how the unit looks like. Thank you.